Numbering system for steel as a millwright, it is important for us to understand the last two digits in numbering system. So numbering system could be 4 or 5 digit number, and usually you can look up a table and you can identify, for example, nickel, chromium, steel will have 32 and then XX. So last two digits will identify carbon content, which is important for us uh, to understand because that tells us how hard it is or whether we can use a hardening process to impart hardness onto steel. So you will very likely end up with mild steels, which is 1018. Uh, if you want to harden something, then you will have to go within 400s, 4000s, so 4340, and so on, where 0.40 is the carbon content. So if you're working with 4140 steel, it means that last two digits of that steel shows you the carbon content. So with 4140, you can start hardening that. And higher carbon content, harder the steel may be after heat treatment. Regular carbon steel broken into three groups: low carbon, medium carbon, and higher carbon. Low carbon steel with carbon content up to 0.3 cannot be hardened. So it could be used for case hardening, which means if you have a round stock, just the outside of it, maybe first 5 thousandths of an inch, could be hardened. So it just goes through a regular hardening and quenching process. But if you want something harder, then you have to either stick with medium carbon or high carbon content. So higher carbon content means it will be much, much harder and it will harden all the way through. Now, on the other hand, anything over 1.7% carbon considered to be cast iron. So gray and white cast irons, they have 3-4% of carbon. Then you will come to alloy steel. Again, alloy is a combination of two or more metals, and you can read about different combinations of alloy steel. Tool steel, so that's the HSS abbreviation or HS abbreviation found on drill bits, dies, molds, jigs. It will have a very high carbon content and it will be hardened to a very hard condition. And two types of high-speed steels are tungsten and molybdenum. You can actually get drill bits in molybdenum M and type T, which is tungsten. So they are more expensive in high steel combination than regular high steel, regular HSS steel. And then you will read about stainless steel. There's 3 different styles or types of stainless steel depending on what alloy it has. Austenitic will have chromium and nickel. Ferritic stainless steel will have chromium but not nickel, and so on. Then aluminum. Aluminum is the most widely used industrial material because it's fairly light and it's corrosion resistant. Then again, pure aluminum is way too soft, and therefore what we use as millwrights, it's an alloy because of other metals added to make it tough. Copper and its alloys, brass and bronze. So both brass and bronze have copper in its content. Copper by itself is way too soft for us, but we do use brass and bronze, and most of the time, or a lot of time, brass in bushings and bronze. So one of them is tougher, one of them is harder. So you can read about two materials, and as you do so, please pay attention to beryllium bronze. Because it's very toxic. So you can actually handle it, no problem. But if you're cutting it on a lathe or milling it, Just be aware that the particles produced during machining processes are very toxic. Therefore, you have to wear proper PPE.